Good morning, friends. Our topic is to determine the band gap of semiconductor. The context we learn here are introduction, energy band, valence band, conduction band, energy gap, semiconductor, and conclusion. The given figure shows the forbidden gap between the metal semiconductor and insulator. As we know, in metal, the forbidden gap is not there, and in semiconductor a very small gap is present between the valence and conduction band, and in insulator a very large gap is present between the valence and conduction band. In introduction, silicon electron equals to 4 electron, 1s2, 2s2, 2p6, 3s2, 3p2. 4 valence electrons present in the outermost orbits are called valence electrons, and their behavior decide the electrical characteristics material. For silicon, 2 electrons are present in 3s and 2 electrons are present in 3p orbital. Consider n silicon atoms which are far apart from each other so that the interaction between them is negligible. In this 2n electrons occupy the 3s level and 2n electrons in 3p level. When the atoms are brought closer, the interaction between them increases and they now form the electronic system. In energy band theory, three important energy bands are valence band, conduction band, and forbidden band. Valence band of energy level which are closer to the nucleus. Second point, an electron valence band experiences strong force of attraction nucleus. Conduction band of energy level which are far away from the nucleus. The conduction band is the band of orbital that are high in energy and are generally empty. Forbidden band or energy gap. In solid state physics, an energy gap or band gap is an energy range in a solid where no electron states can exist. It generally refers to the energy difference between the top of the valence band and the bottom of the conduction band in insulator and semiconductor. In this given figure, we have to know various energy band gaps in material. As we know, in insulator, the band gap is very large that the electrons can't jump from the valence and conduction band, so it can't conduct conductivity. In semiconductor, a very small gap plays between the valence and conduction band, and in conductor, there is overlapping of valence and conduction band, so the electrons are directly jumped from valence band to conduction band and the electricity is generated. In semiconductor, first, the material in which the conduction and valence band are separated by small energy gap 1 eV are called semiconductor. Silicon and germanium are commonly used semiconductor. A small energy gap means that a small amount of energy is required to free the electron by moving them from the valence band and conduction band. The semiconductor moving like insulators at 0 Kelvin because no electrons are available in conduction band. It is a circuit diagram of semiconductor. The formula used to find the band gap energy is slope of line upon 5.036 eV. From the given figure, we come to know that the band gap of a semiconductor is 2.03 eV. Then this is the graph between the temperature of diode versus the reverse current of PN junction diode. It is the graph of temperature of diode versus reverse current of PN junction diode. The graph is plotted between log of current and 10/3t that comes to the straight line. Then by calculating, we get the value that is 2.03 eV. So from this, we have concluded that the energy band gap of semiconductor tends to decrease as the temperature is increased. The experiment was concluded and proven that band gap energy between the conduction band and the valence band is approximately equals to 2.03 eV.